Dear students, in previous class we discussed the absolute convergency of some series by using the different tests, root test, ratio test and limit comparison test. So in this class we are going to some other problems like this. Consider the series sigma log n all raised to minus n. Sigma log n all raised to minus n. What about the series? Is it absolutely convergent or not? So, consider let xn equals log n all power minus n. Then what about xn power 1 by n? Xn power 1 by n is log n all power minus n all power 1 by n. All power 1 by n. That equals log n power minus 1. N and n cancelling each other. That is modulus of xn power 1 by n equals modulus of 1 by log n. Agreed. Log n all power minus 1 means 1 by log. So what is limit modulus of xn power 1 by n? Limit modulus of xn power 1 by n is, it is limit modulus of 1 by log n, that is 0. Okay, 0 strictly less than 1. So by root test, here sigma, here r less than 1. When r less than 1, then sigma modulus of xn is convergent. That means sigma xn is absolutely convergent. So the series sigma log n all power minus n is absolutely convergent. Agreed. Now check the convergence of another one, sigma 2 power n into e power minus n. Is it absolutely convergent or not? Sigma 2 power n into e power minus n. Is it convergent absolutely or not? How? Again, by the same argument, let xn equals 2 power n into e power minus n. So what is xn all power 1 by n? Xn all power 1 by n is 2 into e all power. Okay, so it is 2 by e itself. Xn all power 1 by n is 2e by this is nothing but 2 by e all power n. 2 power n into e power minus n is 2 by e all power n. So xn all power 1 by n is 2 by e all power n all power 1 by n. That is 2 by e. What is 2 by e? Is it greater than 1 or less than 1? E lies in between 2 and 3. So 2 by e is strictly less than 1. Okay, 2 by e less than 1. That means therefore modulus of xn power 1 by n equals modulus of 2 by e. So it is strictly less than 1. Means therefore its limit. Limit modulus of xn power 1 by n strictly less than 1. So by root test, the given series sigma 2 power n e power minus n is absolutely convergent. Okay. What about the next one? Consider another series sigma n power n into e power minus n. Is it absolutely convergent or not? Sigma n power n into e power minus n. By the same arguments, let xn equals n power n into e power minus n. N power n into e power minus n means it is n by e all power n. Agreed? Okay. Therefore, xn power 1 by n. What is xn power 1 by n here? It is only n by e. Sure. So, therefore, limit modulus of xn power 1 by n. Limit modulus of xn power 1 by n. Limit modulus of xn power 1 by n equals limit of modulus of n by this modulus of n by e is always greater than 1. Okay, for all n greater than 2. For all n greater than 2. So means here r greater than 1. R greater than 1 means sigma by root test, sigma xn is not absolutely convergent, means it may diverge. Agree? Now consider another series, sigma e raised to minus log e. E raised to minus log. So sigma, consider the series sigma e raised to minus log n. How? What is e raised to minus log n? E power minus log n equals 1 by e power log n. Okay. What is e power of f of x? E power of f of x is f of x itself. So e power of log n. E power of log f of x. We have e power log f of x is f of x itself. Okay. So e power log n equals 1 by n. Therefore, e power log n, e power minus log n equals 1 by n. That means sigma e power minus log n equals sigma 1 by n. Agreed? But what is sigma 1 by n? Sigma 1 by n is a harmonic series. It is diverges. So by limit comparison test, sigma e power minus log n is also diverges. Clear? Okay. Then consider another result. If a and b, suppose a and b are any two positive numbers, then a and b are positive. A comma b are positive numbers. Then prove that sigma an plus b, sigma an plus b, a into n plus b all power minus b, which converges if b greater than 1, comma diverges if p less than 1. Sigma an plus b all power minus b, which converges if p greater than 1 and diverges if p less than or equals 1. Okay, if p or strictly less than. So we know that sigma 1 by n power p converges when sigma 1 by n power p converges when p greater than 1 and diverges when p less than or equals 1. Enough. So the proof is in this way. Let xn equals 1 by an plus b all power p or an plus b all power minus p, and yn equals 1 by n power p. That yn equals 1 by n power p. So what is xn by yn? Therefore xn by yn equals, come on, 1 by an plus b all power p all divided by 1 by n power p. Clear? So that equals, come on, n by an plus b all power p. Okay, n by an plus b all power p. So xn by yn equals that one. So therefore limit modulus of xn by yn equals limit, what I get? You can cancelling this n and n, 1 by a plus b by n all power p. Enough. So you can apply the limit equals limit 1 by a plus b by n. What is limit of b by n? 0. So 1 by a power p. Agree? Okay. So But by comparison test, what is limit comparison test? Sigma xn converges if and only if sigma yn converges. The limit comparison test states that sigma xn converges if and only if sigma yn converges. What is sigma yn here? Sigma yn means sigma 1 by n power p. Enough. So sigma 1 by n power p converges if p greater than 1. According to this argument, therefore sigma xn converges if p greater than 1. 1 by a power p greater than 1. Similarly, sigma xn diverges if p less than 1. Enough. So by using limit comparison test and by the choice of yn, it is 1 by n power p. Sigma xn converges if and only if sigma yn converges. But sigma yn is sigma 1 by n power p that converges when p greater than 1 and diverges when p less than 1. So we have, when a and b are positive numbers, then sigma an plus b all power minus p, or sigma 1 by an plus b power p converges when p greater than 1 and diverges when p less than 1. Agree? Okay. Now there is another result. There is the three important tests are limit comparison test, a root test, and a ratio test. Now the another one is, it is a Rabe's test. Rabe, R-A-B-B-E-S, a Rabe's test. So listen. When the ratio test fails, Rabe's test is used when the ratio test fails. What is Rabe's test? Rabe's test means the statement is let x equals xn be a sequence of real numbers. If there exists a real number a greater than 1, a is any real number, there exists a real number a, comma a greater than 1, and k is any natural number. For any natural number k, then such that modulus of xn plus 1 by xn, modulus of xn plus 1 by xn less than or equals 1 minus a by n. Modulus of xn plus 1 by xn less than or equals 1 minus a by n for all n greater than or equals k, then the series sigma xn is absolutely convergent. Let x equals xn be a sequence of real numbers. A is any real number with a greater than 1. Then there exists a natural number k such that modulus of xn plus 1 by xn less than or equals 1 minus a by n for all n greater than or equals k, then sigma xn is absolutely converges. And if a for n r with a less than 1, then there exists a natural number k such that modulus of xn plus 1 by xn greater than 1 minus a by n for all n greater than or equals k, then sigma xn is not absolutely converges. So this is Rabe's test. Xn is a sequence of real numbers. A is greater than 1. A is any real number. For k is any natural number. If modulus of xn plus 1 by xn less than or equals 1 minus a by n, then sigma xn is absolutely convergent. And for a less than 1, modulus of xn plus 1 by xn greater than 1 minus a by n for all n greater than or equals k, then sigma xn is not absolutely converges. How to prove this one? So the proof is, first consider if this holds. Modulus for a is a real number, a greater than 1, and modulus of xn plus 1 by xn less than or equals 1 minus a by n for all n greater than or equals k. For k is a natural number. If it holds, what happens? So if it holds means we have modulus of xn plus 1 less than or equals k into, by taking LCM, 1 minus a by n. What is 1 minus a by n? 1 minus a by n means n minus a by n. Okay, so it is k into n minus a by n. Modulus of xn minus 1, xn plus 1 less than or equals, modulus of xn plus 1 less than or equals n minus a by n into modulus of xn. Okay, if the result holds, if the first result holds, then from there we have modulus of xn plus 1 less than, first inequality holds. Then modulus of xn plus 1 less than or equals n minus a by n by mod xn. That means, what is modulus of xk plus 1? Replace n by k. So xk plus 1 less than or equals k minus a by n. Okay, so it is k minus a by k minus a by k into modulus of x. Okay? That means k into modulus of xk plus 1 less than or equals, it is k minus a into modulus of x. That means k into modulus of xk plus 1 less than or equals, k minus a can be rewritten as k minus 1 plus 1 minus a. Okay, introducing 1 and minus 1 simultaneously. So this into modulus of xk. Agree? That means k into modulus of xk plus 1 less than or equals, it is k minus 1 into modulus of xk plus 1 minus a into modulus of xk. 1 minus a into modulus of xk. That means k into xk plus 1 minus of k minus 1 into xk, it is less than or equals 1 minus a into modulus of xk. But what is a? A greater than 1, that's the choice of a. A greater than 1, so 1 minus a should be negative. Sure, 1 minus a is negative. That means k into modulus of xk plus 1 minus k minus 1 xk is negative. That means k into modulus of xk plus 1 strictly less than modulus of less than or equals 0. So it is less than or equals less than or equals k minus 1 into modulus of xk. K minus 1 into modulus of xk. K into modulus of xk plus 1 less than or equals k minus 1 into modulus of xk. So you can immediately conclude that k into xk plus 1 is a decreasing sequence. That means k into xk plus 1 is a decreasing sequence. Okay, decreasing sequence. Now again, consider this result also. Consider this result. K into xk plus 1 less than or equals k minus 1 plus 1 minus a, or less than or equals k minus 1 into mod xk plus, or come to this one, k into xk plus 1 plus, it is minus k minus 1 xk less than or equals 1 minus a into xk. Consider this result. Mark it as 1. K into xk plus 1 minus k minus 1 into mod xk less than or equals 1 minus a into mod xk. From here, you can multiply throughout by negative. What it is? It is k minus 1 into mod xk. Okay, k minus, if you multiply throughout by negative, so it is k minus 1 into mod xk, then minus k into mod xk plus 1. Enough? Okay. It is greater than or equals minus of 1 minus a, that is a minus 1. So it is a minus 1 into mod xk. If you multiply it by negative, the inequality should reverse. So k minus 1 mod xk minus k into mod xk plus 1 greater than or equals a minus 1 into mod x. A minus 1 into mod xk. Okay. Now you can replace k by k plus 1. Replace k by k plus 1. What do you get? If you replace k by k plus 1, this is k by k plus 1 means it is k. So it is k into mod xk plus 1 minus k plus 1 into modulus of xk plus 2. Okay, greater than or equals a minus 1 into modulus of xk plus 1. Agreed? Again, you can replace k by k plus 1 here. What do you get? It is again the next term is k plus 1 into modulus of xk plus 2 minus k plus 2 into modulus of xk plus 3 greater than or equals a minus 1 into modulus of xk plus 2. Proceeding like this. Finally, replace in this case here 2. Finally, replace k by n in 2. When k is n in 2, what do you get? It is n minus 1 into modulus of xn minus n into modulus of xn plus 1 greater than or equals a minus 1 into modulus of xn. Agreed? Okay. Then you can add in vertical. If you add this vertically, what do you get? By the vertical addition, finally you have you can add k into xk plus 1 from here also. Adding vertically k into xk plus 1, then here it is as minus k minus 1 xk. So minus k minus 1 xk less than or equals 1 minus xk and so on. If you are adding vertically, what do you get there? There you have k minus 1 into xk, k minus 1 into modulus of xk, come on, minus n into modulus of xn plus 1 minus n into modulus of xn plus 1 greater than or equals, here a minus 1 is commonly taken outside. What means here? Modulus of xk plus modulus of xk plus 1 plus etc. plus modulus of xn. Okay, right. That means here modulus of xk plus etc. plus modulus of so from here it is modulus of xk plus etc. plus modulus of xn less than or equals this one, k minus 1 into modulus of xk minus n into modulus of xn plus 1 divided by a minus 1. Enough. So means this is the sequence of partial sums. So modulus of xk plus etc. plus xn means sequence of partial sums of Sn.